Today's topic will be Cancer Neuroscience, State of the Field, and Emerging Directions. This is an article written in Cell, and it is covered and authored by Frank Winkler et.al. Firstly, what Frank and his colleagues are trying to elucidate in this paper is that the nervous system is intricately tied to cancer diagnosis, whereas usually cancer can only progress if the nervous system has, if it's able to co-opt the nervous system in its development. Usually there is developmental milestones that occurs in life, and when you look at cancer based on this paper, what what Frank Winkler is trying to elucidate is that cancer tends to act like the birth. It tends to act like as if it's a new living system by itself. And usually, when a new living system starts, it tends to be very rapid in its growing, and the body usually tries to do whatever it can to sustain it. So it's almost as if like the cancer tricks the body into thinking that it is a life that needs to be taken care of, and therefore it needs to be innovated with the right nerves, the right blood vessels, the right food, or the right nutrients, as well as limited or actually immune suppression towards it, so that it doesn't stop growing. So what they're trying to say here is that when we're targeting cancer from now on, we need to see if we're going to be cutting the nerves that are feeding it, because from this paper, they have discovered that when they denerve certain cancers, or they cut them off from nerve stimulation, the cancer tend to die off. But if you kill the cancer, but it's not nerve, but the nerve is still connected to it, in most cases the cancer will always come back, and even can be even more severe in that case, because in those cases when it's very intricately tied with the nervous system, it becomes metastatic and is able to kind of co-opt itself into other organic systems and make treatment much harder. So it's good to look into that. In most of the in what in the short form of it is cancer therapies might facilitate further pathogenic conditions, um, because they're not really killing the entire system. If they're just targeting the cancer itself, they have to target the cancer as well as the nerve agents that are linked to the cancer. So Frank and Wickler start their discussion in this paper by essentially explaining how the growth of a new nervous system occurs. Usually in that state, uh, it's very rapid, and and everything in the body will essentially grow toward essentially making the system work properly. So in the sense, they're saying that when an axon starts, when it's born, it has it has little shoots, or neurites that it shoots out. Those neurites tend to search for other axons, and eventually once they connect to each other, they start to fire together, right? But usually in the beginning, as we all know, there is an overabundance of neurons, so this always has to be cut off at a certain milestone. And usually when that happens, it helps the nervous system refine itself so that uh, it can do the proper physiological functions without any problems. In this paper, they're saying that cancer starts the same way. Cancer usually starts by a small bud, and when it when it goes unchecked, it starts to bud off. And the way it buds off if that's by taking a blood vessel, or by co-opting some nerve cells to come and fuel its growth, either by usually they would secrete certain factors that are usually secreted during development to help the growth of that cancer. And if it does it by that, it can grow more and essentially bud off and become metastatic. So in this paper, they're covering essentially all that, and how it is important to look at the entire system when you're fighting a cancer. And even when you're fighting the cancer, you have to ensure that you 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 look at which nervous system was innervating it, and if that nervous system has any bits and pieces left of that cancer when you have um, quote I'm using overhead coding to